change like phenomena, how feasible it is, that is what we are going to discuss. So, first of all, to give you the idea that why this particular topic is in news. So, last week itself Brussels, that is the capital of Belgium, it has hosted the first of its kind nuclear energy summit that was billed as the most high profile international meeting on nuclear energy ever, boasting the attendance of representatives from 30 countries including a few heads of the state as well. This was the latest in series of efforts being made in the last few years to pitch nuclear energy as an important solution to global problems like climate change, which is largely driven by use of fossil fuels, especially carbon and petroleum, natural gases, as well as enhancing the overall energy security of the world, taking into consideration also the volatile situation that has erupted few years back in Europe due to the Russia-Ukraine war. The International Atomic Energy Agency, that is IAEA, has called it as a landmark and a turning point in the efforts to expand the use of nuclear energy for generating clean electricity. Now, in this context, let us try to make a case for nuclear energy and how potentially useful it can be. So, the case for nuclear energy as a possible substitute for the fossil fuels, at least for electricity generation, is not without merits. Obviously, it is a clean source of energy because it has minimal carbon footprint. Carbon footprint, basically it means that the amount of carbon based gases that can be released during the process of energy generation. There is negligible release of emissions, especially if you talk about greenhouse gases during the electricity generation process. And even when the entire life cycle is considered, GHG emission are only in the range of 5 to 6 grams per kilowatt hour as per IAEA from the nuclear energy. Now, this is more than 100 times lower than coal fired electricity and about half the average of solar and wind generation. That means what we can say, that nuclear energy is not only cleaner than the coal based thermal power production, but also it is better than renewable energy generation such as solar and wind energy generation based plants. However, it has certain advantages, which is why a lot of countries have adopted it in last 50-60 years. The most important advantage that we can highlight here is its perennial availability, unlike wind or solar, which are season or time dependent. Second, we can say, due to these kind of characteristic, it is suitable for base load electricity generation that solar or wind projects are unable to do unless breakthroughs in battery storage technologies come along. What it means, or what it tries to explain, that if we cannot be fully dependent on solar or wind energy generation, we have to have a thermal energy based or some other energy generation, some other kind of fuel based electricity generation plant, and then solar and wind energy can complement it. We cannot use solar or wind as a base electricity generation plant because of the problem that they are having in seasonal availability or perennial availability. However, that is not case with the nuclear energy generation. And for these reasons, nuclear energy features prominently in most of the decarbonization pathways that is suggested by the IPCC, that is Intergovernmental Panel on Climate Change, and also other organizations working in the area of energy security. Now, this is a graph that represents the global nuclear electricity generation capacity in gigawatts, and if you try to look it over last 20 years or so, we can see that from 2003 to 2010, we have a slight increase or a stagnancy, somewhere about 370 gigawatts capacity overall global scale. However, from 2011, we can see there has been significant reduction. However, again from 2015, we can see an uptick in the nuclear energy generation, and again it has become stagnant in somewhere about 370 to 360 gigawatt level. On the other hand, if you look at the number of reactors globally by the age, so most of the reactors in the world are aged 40 to 50 years, that is 127. Then at the second number, we have reactors that are aged about 30 to 40 years, and then we have some other numbers as you can see from this particular graph as well. Now, why, despite so much advantages that we have discussed nuclear energy offers, why there is a poor uptake of nuclear energy, especially in the least developed or developing countries? So, this we can understand from some of the challenges that the nuclear energy generation faces. First is, there is a serious lack of enthusiasm for the accelerated deployment of nuclear energy, not only in developing countries but also in the developed countries. Second, this we can understand from this fact that only 31 countries in the world today, out of more than 194, use nuclear energy for generating electricity, and barely 7 more are working toward joining this club. Now, decrease in the number of operation nuclear reactors in the last 20 years is a big setback that IAEA has highlighted in the nuclear energy sector. Plus, if we talk about even in those countries which are consuming or generating nuclear energy, there has been marginal increase, and this we can understand from the fact that total installed electricity generation capacity from about 360 gigawatt in 2003 to only 370 gigawatt now. That means in last 20 years or so, the capacity addition of only 11 gigawatt has happened in this particular sector. So, thus nuclear energy account for less than 10% of global commercial electricity generation, and its share has been declining for almost 3 decades now. If you take a look at this particular table, you can see that as of now, United States is a leading country which has highest number of operational reactor. Then at second number we have France, China, Russia, South Korea, and India stands at the sixth state with total number of active reactor as 90. So, what are the major constraints that has basically limited the capacity addition in nuclear energy generation or decline also in many countries? So, first of all, the nuclear energy plant itself is a high investment and technology based plant that takes years and years to basically build, as we have seen in many plants in India also, such as Jayanagara nuclear power plant or Kottapalya or Karnataka. Now, time taking nature of this plant, and also they have to operate under a variety of regulations and constraints, especially the government, that makes it not very affordable, especially for the low income countries or the developing economies. Second, there has been lack of any kind of technology breakthrough that we have seen in other sectors in last 10 or 20 years or so, especially if we talk about the solar or wind energy sector. So, the much discussed technology of a small modular reactors is also far from being mature. Due to this reason, the adoption rate of solar and wind energy is much more higher as compared to nuclear energy, and it is hurdle like this that have worked against rapid growth in nuclear energy in the last 3 decades, as we have seen from the table before. However, the climate emergency is creating an opportunity, and experts believe that maybe in future this will change. For a greater push for nuclear energy will have to take at both developed country level as well as developing countries level. Now, what is India's position as far as nuclear energy is concerned? So, currently India has total 23 operational nuclear reactors, and also in its climate policy, many times India has acknowledged that nuclear energy is going to play a very important role as far as its decarbonization plan, that means reduction of carbon emission is concerned, and also India is planning for rapid expansion of nuclear energy in the coming years, and that is why it is collaborating with large number of countries such as US, France and Russia. The share of nuclear energy in total electricity generation capacity in India still is very less. It just contributes to about 3.1%, among the lowest in the countries that do use nuclear energy, and that is something that is a cause for concern. However, Government of India in its plan has highlighted that it is going to expand its nuclear capacity over 300% by year 2031. For now, currently we have the total nuclear energy capacity production of 6,780 megawatt, and government is trying to increase by 2031 to almost 22,480 megawatt. So, obviously the basket or the composition basket of energy is going to change in India, with nuclear energy getting a much more bigger share, much more bigger stake. So, overall, what we can say in conclusion, in recent interview it has been summed up very well by former head of the Department of Atomic Energy, Dr. Anil Kakotkar, and he says and he believes that India was not moving fast enough to expand its nuclear power sector, especially in last 10 years. And thus he expressed surprise that India is staying away from also the tripling declaration that was signed at COP28, and he has said that India had the potential and also the imperative to grow its nuclear energy sector at a much more faster pace, which we might be seeing in the coming decade also. So, that is all for this particular video. I hope you understood overall about the nuclear energy and its potential in the area of climate change. Thank you very much.